Hello, and welcome to our lesson on Precision DACs. In this video, we will discuss power on glitch and what you can do to mitigate it. Imagine that you are working in a motor drive application, and as you power on the system, the motor moves a little. In this and many other applications, this kind of behavior is unacceptable. What caused this sudden movement? It might be the DAC creating a large power on glitch. The cause for a power on glitch within the DAC can be due to a couple of different reasons, depending on the output topology of the DAC. The 350 millivolt depiction shown here is actually a very forgiving scenario. Sometimes you can see 2 or 3 volts at the output. Let's look at the how and why of a DAC producing this error. The power supply starts ramping. The pre-output stage requires a minimum headroom voltage, VH, to start functioning correctly. But this voltage is usually lower than the threshold voltage, VTH, that is required by the PFET on the output stage, which can sometimes be as low as 0 volts. This can cause Vout to track with the power supply, having output power on glitches in the 2 or 3 volt range, which will have a large amount of energy. The glitch ends when the supply reaches the pre-output stage VH and the output stops tracking the supply. For dual supply DACs, the result can be very similar, but the output instead tends to track with the reference voltage, so powering on the reference after the other supplies can greatly reduce power on glitch. So what can be done to reduce this effect? There are only a few ways to reduce power on glitch. A filter will only spread the energy out over time, but will reduce the amplitude. However, in most cases, the energy is so large that this method is still unacceptable, as the output will take too long to settle back to the desired voltage. You can also try adding a small resistor to ground in parallel with the load. This can allow the DAC to quickly dump some of the energy to ground, but has some undesirable side effects. Current consumption will increase, and the DAC output voltage may droop during normal operation. Keep in mind that this behavior is most prominent in older devices, since newer products include on-chip mitigation of power on glitch. However, if you are indeed running into this problem, the best fix is to add an external output grounding circuit. The principle here is that the output is tied to ground by a switch while the DAC is powering on. Once the supplies are completely powered on, the DAC can resume normal operation. Software is not required if a supply detect circuit like the one shown here can be implemented. The sizing of the resistors will change the point at which the supply detect circuit turns on and off. See the comments section of this video for a link to an article with a more in-depth explanation of power on glitch mitigation. Thank you for watching this video on improving power on glitch when designing with Precision DACs. Please watch our other videos on Precision DACs, or go to ti.com/PrecisionDAC to learn more.